All right, we'll go ahead and get started. So first, thanks to Elizabeth for organizing this and inviting everybody here. So this talk is going to be about just beginner Git tips and tricks. Git is a hugely deep topic, and as I was putting this talk together, I wanted it to be about 30 minutes and with some demo, with some live demo. And it was just so difficult to cover all the things I wanted to cover. So I decided to pare it down a little bit, and as in the style of launch school, the focus is going to be on helping you understand. Sometimes, you go to these talks and there's a lot of amazing things that you see, but none of it really helps you on a day-to-day level or helps you understand something more fundamentally. So I'm trying to strike a balance of forcing you to understand Git at a more fundamental level and without going too deep, where we can just spend hours and hours talking about it, and also balance out with some practical tips. Right. So I produced like 10 tips here in this presentation. I don't know if they're the best tips, but they're 10 tips that I thought would help perhaps myself earlier in my career had I known these tips earlier. This is by no means comprehensive. Again, Git is a hugely deep topic, and there's books and books written on this topic. So we're going to do our best here, and mostly I have an eye towards helping people at launch school. So, for example, we're not going to talk too much about collaboration, just because in launch school you don't deal with that until capstone, where we're working together. But most of the time you're working by yourself, and it's just about sort of how to enjoy Git a little bit better, so that you understand a little bit better, so that you enjoy working with it a little bit more. If you have any questions, feel free to ask during the presentation. We'll keep it pretty informal. If questions pop up, I'll probably just pause and answer it, so we can take this presentation any direction you want. But I want to keep in mind that the primary audience is going to be people that have finished our launch school Introduction to Git and GitHub book. So, have the basic commands down, have probably committed something, have pushed something to GitHub, but not too much beyond that, right? So in that middle slot there. So here quickly are the 10 things that I decided to cover. A little bit of theory with practical recipes, right? Understanding distributed version control systems, configuring, sort of having the right mental model of Git, where it expects you to understand that there's this thing called a working directory, an index or a staging area, and a local repository. How it deals with files and the life cycle of files. And then we get on to a little bit more practical things like using GUI and using branches, and then back to a little bit more theory in terms of paying attention to commit hygiene and how that impacts your history. And this might come into play if you are thinking about building some sort of project to impress employers. They're going to look at your GitHub history, and this is where your commit hygiene might be important. And then finally we'll end it with a couple more recipes in terms of how to undo stuff. Not as easy as hitting undo, unfortunately, and then stashing work in progress work. All right, this is what you should already know, right? If you've read the book. If you haven't read the book, here's a link to it. I think it's a really great intro for those who are very new to version control and obviously to Git. So it's sort of a type-along book. So Git init, how do you kick off a repository? Git init or git clone. Git init is to initialize a brand new repository locally, right? This is all local. Git clone is also local, but it's working with remote, and that git clone is usually you're cloning it from some sort of remote repository and bringing it to your system. And then once you have that repository, Git repository, you can work with it by adding to the index or staging area, and then you commit it to the local repository. And the Git status gives you a sort of a dashboard view of your Git repository in terms of what's committed, what's not, what's tracked. And then, of course, git push origin master. This is probably a command, again, if you use the book, if you've been at launch school for a while, this is a command you probably are used to typing out a lot. And this is just pushing all your commits to origin onto the master branch. Origin is usually GitHub. Right, we'll kind of demo that real quick. I think here we have a Zoom feature here. You can raise your hand or something like that. I'm kind of wondering how many people have not read this book or are not familiar with these commands. Let me see if there's a... I thought there was a feature here to raise your hand or something like that. On the top left, okay. All right. Okay, so we'll do a quick demo. I've prepared a repository here, just a random repository called 97 Things Every Programmer Should Know. Very specific, only 97. And then so I'll clone the repo. So that's going out to my my GitHub repository or a remote repository. I kind of don't want you to think about GitHub or not GitHub. A lot of people conflate Git with GitHub, which is not the right way to think about it, right? So you're going to somewhere, right, specified by this URL somewhere, and you're pulling down, you're cloning this repository. And now if I look at my file system, I have this repository. So I can go into this Git repository, and if you notice my little prompt here changed to master. This is not a tip. I did not include this tip in my presentation, but I was thinking about it just now, and this is actually really helpful to just understand what branch you're on. So I really recommend modifying your prompt and giving you a hint as to what branch you're on. So you'll see my prompt change a little bit here as we do things. And then I'll just pop this open in my editor here, which is off screen. Grab that real quick. So this is the project. This is that 97 Things Every Programmer Should Know. I guess it's in English and Russian. And then here's a couple things. And it's all in just markdown files, which is nice. So thing one, thing two. And then I'm going to make some change here. So, so I'm within a Git repository. I can decide to add a new file here, right? I can just say, let me see if I can say new file. Another thing here, there's no extension. This is probably a bad file name, but I'm going to go ahead and change that file name just so that it adheres to normal standards. And if you notice that when I added this, I have this little X that popped up. Again, that's my prompt. That just tells me I have uncommitted changes. And I should be careful, right? I should think about doing something with that. So if I'm back to my root directory in my project, and if I do a git status, you'll see that I have this color here, right? It's telling me that this thing is new, it's untracked. So to track that, or to get that into my, so you have to type this all out, kind of annoying. And now it's green, right? It says changes to be committed. So in other words, this is now staged, right? So there's the idea of this working directory, which I was working on before, working on files in a working directory. And then now when I say git add, I've added it to the staging area. Sometimes it's called the index. So I've added it to the index. And this is the staging area where everything is ready to be committed, right? Everything's ready to be committed. So I can keep working here, or I can build a commit. So the commit is like the package that Git works with, right? So I want to try to package everything into neat little commits. So I can modify another file. So if I just do something here, and if I do a git status, you'll see that now it'll say this file is modified. This README file is modified. And again, I can just do git add. If I just do period, it will add all changed files in the working directory, and it will add it to the index or staging area. So I got 2 files now staged, ready to commit, right? And so finally, I can build my commit. I'll pass it the end flag, which is a message, right? Fix some typos or something like that. And now if I do git status, and this is another confusing thing about Git that confuses a lot of people, is that when you do a git status and there's nothing there, you're like, oh, I'm done. There's somehow, work is done. And that's true if you're only working locally, right? So if you're working with a collaborator on this Git repo, GitHub repo, that commit doesn't show up. So I'm going to click through here, and you'll see that that commit does not show up. Hang on a second. Right, so it's not there. So at least within the realm of launch school, the final step that a lot of people take is to push this to a remote repository so that we can see, we can share it with maybe a TA or something like that and say, hey, I have this issue, right? Here's some work in progress. Can you please take a look at this, right? Everyone at launch school is used to this. So you have to push this to GitHub or somewhere that people can see it. And now there's a nice little diff. It's in the commit history. So this is now living on GitHub. So that's generally how we've been teaching people to work, right? You work through this process of working locally, add, commit, and then you have to push your commits to some place. Got a couple questions here. I'm using a Z shell, but these commands are not shell specific. And if you're wondering about the prompt, I would say just Google it for your specific shell. There's many ways of modifying your prompt. But I'm using Z shell. I'm using a plugin called Oh My Z Shell, and it's like a little framework, and that has a Git plugin. Not sure I would recommend it to everybody because it's really heavy and it's really slow, which I dislike. So I might be moving away from it. But I did this a long time ago. Why is that yellow X on you after you staged it? Why is there a yellow X? So this is up to you in terms of, so I don't want people to focus on a prompt too much, but I've decided to notify me whenever I have changes that are not committed, right? So this is not a Git feature. This is just sort of my personal preference. Okay, so let's go back to the presentation. So it's a quick demo of what we already know. Could you talk about how frequently you should commit and how specific it should be? Yeah, that's a good question. I'll actually talk about that later when we talk about commit hygiene. And we'll talk about branches a little bit. So tip number 1 is I think people should understand what distributed version control systems are, because people who are learning programming now, and I've used this analogy a lot, it feels like you're jumping into the middle of a movie. And sort of the world as it is today, it just feels like there's certain characters in this movie that you should know, and you don't know why or for what reason. And, they're just there. And they seem to always be there or have been there. And that's not true, right? So distributed version control systems, not a new concept, but fairly new in popularity. When I first started out in 2002 programming, we definitely did not use a distributed version control system. We used just a version control system, not non-distributed, right? So I want to talk about a couple of ways that you could keep versions of your files, right? So the first and the most simplistic way is just to keep versions of each file. And so your file pointer is pointing to the latest version always. And if you need to do any sort of refresh from history, you would just kind of point this guy to the previous version, right? This is how, if you're familiar with Mac and Time Machine, this is sort of how that works, right? Or I think Dropbox works in a similar way, except Dropbox has this syncing mechanism. But if you just think about it from your local computer perspective, all it's doing is taking a snapshot of that file, right? Either based on time or every time you hit the save button. Very simple to understand, right? And this is sort of how version control systems were first used. And then what people would do is they would email things around or send patches around. And then, so if you did something, you would email it to me or upload some FTP, and I would download it and say, oh, okay, I apply the patch. And then we're both in sync, right? Very manual. But it's only within the realm of like a local computer. Of course, that prevented any sort of collaboration. And so when I started my career, this is the type of version control that I was introduced to when I first started. So used proprietary version control systems like CNBC, CVS, and then Subversion. Subversion was the primary one. Even today, if you look at some Git documentation, a lot of it will be like, oh, if you're coming from Subversion, watch out. These are the gotchas. And so if you've never heard of Subversion, you're like, why are they talking about that? Who cares about Subversion? I'm here to learn Git. But Subversion was Git before Git. And its model was like this, in that your local computer only had a certain number of files that you could work on, and the true source of truth, the source of truth for files lived somewhere else in a central VCS, version control server, right? And certain systems, I believe Subversion doesn't do this, but certain systems had what they call pessimistic locking, in that when you worked on a file, you locked it, right? So I'm going to work on, thing one's README, right? Back to our example. So if I'm working with Elizabeth on this project and I'm modifying this file, I don't see all the files in my system. I would have to check out this file, check it out, effectively locking it so that she cannot modify it, right? And again, if you're used to Git, that sounds crazy, but that prevented any sort of collision at all, right? So that's pessimistic locking. And then there's optimistic locking, which is what Git is. Like, anybody can modify any file, and then, we'll figure out how to resolve the differences later, right? So you could run into problems where two people work on the same file, they commit it, and then there's some sort of conflict, right? So central version control systems worked in this way, where the source of truth is somewhere else. And in our computers, developer computers, we would only work with individual files, right? And this is worked okay for many, many years and fine. And then came Git, I should say. Distributed version control systems were available. Git is not the only distributed version control system out there. There's lots of other alternatives, but Git by far is the most popular one. So Git's model is that we actually all have the entire version control database on our machine, right? It's on our machine. So then I can work on the whole project on my machine. I don't have to check out any files. I don't have to worry about whether the central server is up or down. So a lot of times in this model, in the past, I've made this mistake a few times where I checked out a few files and then I went home, after work. And then my colleagues couldn't, and I forgot to check it back in before I left for the weekend or something, right? And then my colleagues could not check out files because I had locked them. So got some bad emails Monday morning. Remember, never do that again, right? So make a note to yourself every day after work to make sure you check in all your files. Otherwise, they can't complete builds. People can't do work. Or if this server goes down. So these are machines, right? And they have to be managed by people. Sometimes they go down. And when they go down, well, you can't code. You can't check out files. You can't commit files. You can't work locally by yourself. And again, that sounds crazy nowadays, but that's maybe why people move to distributed version control. But So this is the idea behind distributed version control. We are all GitHub, right, on our local computer, supposedly, right? And there's no central source of truth. It's really embraced by open source projects, I think, because it removes the single source of failure, right? So if and I should say in this model too, usually one or two people had the keys to this. And if they decided to stop playing and go home, well, there you go, right? You've lost control. You don't have the code. So this was also dangerous from just a political perspective. If you have open source projects controlled by one or two people, and they can just, throw the keys away or take it somewhere else, you don't really have too much power there. So distributed version control's goal is to say everybody has the code, right? So if the person who controls this server computer goes away, well, guess what? It's on this developer's computer, this developer's computer, and so on and so forth, right? So important to understand that. But despite the goal of distributed version control today, if you notice, we still use it in a very client-server perspective, right? So we always say commit things to GitHub, and we'll look at it. Theoretically, you see this arrow here, computer A to computer B. Theoretically, you can just push your commit to my computer, and I can look at it. Right? In practice, that's a little bit harder because I have to set up a Git server, which then I have to give you the URL to, and then set up permissions and private public keys and so on. I have to kind of do what GitHub does, right? And then you can push to my Git server, right? So instead of doing all that, we just say, let's use GitHub or Bitbucket or whatever, and we'll just communicate that way. But the advantage is that we have the entire version control database in our system. We can go back in history. What this does, makes it super fast. So again, if Git is the only version control system you've ever used, you might feel like, yeah, it is fast, because why wouldn't it be? Well, in this model, every action just took forever because you always had to communicate with the version control database, which is across the network, right, somewhere else. If you want to look at the history, right, that's a network call. In Git, you want to look at history, it's just on your computer. Super, super fast. A couple questions here. What is the A flag in the Git commit? A flag, I want to say amend, but I'm not sure. Maybe you can look that up. But N stands for message. All, A stands for all, maybe. So tip number 2 is configure Git, right? Tip number 2 is configure Git. So when you configure Git, just think about there is a way to globally configure Git or on a per project configure Git. On a global level, it's usually sitting in this file. I think there's another file that it could be at, like .config or something like that, but it's usually under your home directory and then under .config. And then on a per project level, it's under .get. These are hidden files, right? This is a hidden directory .get on your project, and this is a hidden file on your system. So, and then config is the file. So definitely look at this. Don't be afraid to look at this, because this is basically how Git knows anything about you. And if you actually delete this .get directory, it's no longer a Git project. It's no longer a project that's being tracked by Git. So a couple of the common configuration variables that is set at the global level is usually your name, your email, and your editor, right? In some rare cases, you want to change your name. Maybe you have sort of a, one for personal projects, like a nickname, and then you have one for your professional work, right? So maybe for the project at your work, you want to use your more formal name with an honorific or something like that, and then a nickname for your other work that you're mess around with on weekends. If you want to see all the configuration variables available, just do a config list. Right? So configuring Git, and then also what I mentioned earlier, look into how to modify your prompts. This is super, super useful. It becomes more useful when you work with branches because it's very easy to kind of get lost. It doesn't give you a lot of visual hints as to where you are. And then set up aliases too. Aliases help a lot. You type these commands out a lot, and this is just a subset of the aliases I have that are, I think, kind of useful. You want to put it in your shell's boot up script or boot up file. So it's usually, if it's bash, it's .bash _ profile. If it's Z shell, it's .zshrc. So whatever file it is, and this is all you have to put in there. So I use all these commands a lot. So instead of typing out every time, just don't do this first maybe, but get used to typing it out. And then once you get sick of typing it out, add it into the alias. Yeah, and this is why I forgot what the flag is, because I just use GCA, and GC is git commit -m for me. And then finally, there's a way to ignore files. So a lot of times in your system, there's just various operating system files or files that you just never ever want to track, and you know that. You can store at the global level, at the system level, or on a per project level. So every project, I think, should probably have a .git ignore file, right? So I just output my system's global ignore, and this type of file is used by OS X to track some metadata about the current directory, and then this tracks the project's Ruby version. It's actually subjective whether or not you want to track this, but this is used by RBM, and so maybe the other developer doesn't use RBM, right? So they don't want to see this file in there. All right, tip 3. This is really not, I don't have too much visual to show anything, but the thing to realize is that most Git commands, you can say all, but it's not true that all, but vast majority of Git commands are local, and you have to mentally understand that. It's all acting on your local repository, right? So git init, add, commit, status, clone. Push is not, right? Push is pushing commits to a remote repository. So, but you have to really, really remember that. I think a lot of people get confused when they forget that you're only acting on your local repository and you're only pushing commits around. That's really it. Tip number 4, this is sort of a mental model thing. And I see a lot of people working with Git and not understanding this. And it just takes, some time to memorize it, and I think it's worth memorizing. So there's this idea of a working directory, a working tree, and then a little bit different in terminology, but roughly the same idea, right? Staging area or index. And then you have your repository, right? So sometimes when someone says repository, people immediately think, oh, that's GitHub. That's not true. You have a local repository, right? Which is inside your .git directory, right? So again, all operations are local for the most part. So when you do a checkout and you are basically saying, give me the snapshot of the commits in this repository, in your local repository, and put it in the working directory because I want to work on it. So if you read this, you'll sort of understand why when you switch branches, right, you say git checkout, because you're checking out a different branch. It's almost like a library, right? And then when you stage fixes, stage files, you're putting them into the index or staging area. And then the commit is going into the repository, right? Commits go into the repository. This is why when you say git push origin master, it's just pushing things here. It's got nothing to do with these two things, these two areas. And this is why you're only pushing commits somewhere else. So this, again, it's a mental model thing. And I think if you, I see a lot of people kind of get stuck when they're working here and then they're trying to push somewhere else, and Like, how come this change didn't make it over there? Why is it so complicated? Why do I have to add? And again, if you just have this mental model in your head, you'll understand why there's so many commands to do relatively simple things. Like, why can't I just work on this and then, send it to GitHub? Another thing to be careful about too is if you use any GUI tools, right? Especially if you use like vendor-specific GUI tools, like the GitHub app, for example. There's ways for you to make a change and go immediately to GitHub. And I think that is okay, but pretty dangerous. Pretty dangerous because they're building like a feature on top of this, right, to make it easy for you. But if you only know how to use GitHub that way, you're missing the entire picture of Git underneath it, right? And in some ways, GitHub wants you to do that, but don't resist that temptation, right? Okay, got a couple questions here. How can I see the history locally? Yeah, we'll cover that in a second. But get log is how you see it locally. When working locally, what is that check out the project step? When working locally, what is the check out the project step? When you're working locally, so when I'm working locally here, I have master checked out. So it's not checking out a project. It's checking out it's basically checking out a branch, right? But basically what a branch is a snapshot of certain commits. And that's all it is, right? So you check out branches. So same repo, you're just checking out different branches. Same repo, same project, right? And usually it's one project per repo, usually. So terminology is a little weird, right? So I want to try to stick to repository instead of project, because I guess theoretically you could have multiple projects in one repository, right? So you're only checking out branches here. Is this just happening behind the scenes when we open file? Maybe follow up with that. I'm not sure I understand that second half of that question. Could you explain from a high level typical Git work when working on a team or even solo project? Yeah, I'm gonna try to stick with the solo project here, just because there's enough sort of complexity to understand it. If you understand sort of these things, then taking the next step of working with a team is a little bit easier. But definitely, I'll cover little things here like feature branch, which is coming up next, and that's pretty much how you would work on a team. You work on a feature branch and then merge back into master. You can also use checkout to get a particular commit on the same branch. You can also use, so that'll be covered in a second as well. So checkout is quite powerful. So if you give it a branch, it'll switch over to that branch. Mentally speaking, you can say it switches over to that branch. If you give it a file, it'll basically grab the file from the repository, which is your local repository again, right? And it'll put it into the working directory, right? So if you say git checkout one file, take it from the local repository, dump it into the working directory, effectively throwing away your, if you have been working on that file, right? So I can give an example of that is, so let's say, this is my alias now, right? My git status, I can use my alias now. Let's say I'm working on this file, right? And I'm just typing along, doing a lot of things. And then you can see there, that's the diff. So that's my alias for git diff. You can quickly see a diff here. And these are the changes I made. And then I realized this is going down a wrong road. This is just absolutely terrible, right? I really don't like it. So this is my alias for git checkout, right? So 01. And you notice that my working directory changes are gone, right? I didn't commit, right? So you can see the git log is how you see history, right? So if you see, if I look at the history, this is a change I made a while back, right? Not this change, a while back. And if I look back here to my, I'll make a more obvious change, but my file changed back too, right? So I'll just make it more obvious. Here's a new paragraph, right? And I wrote a lot and I want to get rid of that. So I'm going to save this. right? There's my new paragraph, git checkout, git status, nothing. And then here's my new paragraph, it's gone, right? So I actually have a slide for this later when we undo things, when we talk about how to undo. All right. Good questions. Anything else? Let me see here. Okay. Let's continue on. Really important sort of mental model. Just remember that, right? So sometimes you memorize commands like, oh, if I just do git checkout file, I can throw away, you know, it'll clobber my current work in progress work. Just remember what it's doing. Taking it from your local repository and dumping it into your working directory, and then you kind of add, commit. All right, that was tip 4. Next tip is similar to the previous, and this is a little bit easier to understand, I think, is that how Git works with files, right? How Git works with files. So it goes from untracked to staged. When you add the file, remember when I added that file, it went straight from untracked to staged. And then there's all these like little, there's 2 sort of intermediary steps between untracked and staged. It goes from unmodified. When you edit the file, it goes to modified. So we'll just kind of do each of these. I already did untracked, right? When I created a new file. I can do it again. It's pretty easy. So let's do new file, a second file.md. So this is, if I do a git status, you'll see that it says untracked files here, right? That means Git is not tracking it yet. And to allow Git to track it, you have to add it. And when you add it, it gets added to the index or staging area, right? So changes to be committed, that means it's in the staging area, and that is what this line is, right? It goes from untracked, it's a file that didn't exist before, you added to your Git repository and you staged it, ready, and it's going to be added to the local Git repository on the next commit. If I have an unmodified file and I edit it, right? If I have an unmodified file and I edit it, it's going to change to a modified state. So again, if I do git status here, you can see that it is modified. And then, and then you can stage the file, right, with git add. I actually showed how to revert this back to unmodified with git checkout earlier, right? So there's another arrow going from modified to unmodified if you just want to throw that away. So and if I do git status, you have 2 files there now. One is the initially untracked one, it says new file, and then one is the modified. And then when I commit, right, it's going to go back to this unmodified state, right? So pretty easy to understand. Actually, I could use my shortcut now. And so again, you have a series of files and build a commit, a bug fix, right? I fixed the bug. And so if I do a git status, it's, you know, there's nothing going on. One nice thing is it does show that, you know, you're ahead of your origin. So if I do a git log, you can see that there's my history, right? A bug fix. So tip number 6 is to use a GUI, right? So, but caveat here, only after you are familiar with the command line. So there's a lot of GUI tools out there. SourceTree is a really powerful one. It's free, Windows and OS X. A lot of people like it. I have it. I don't use it that much just because it's very powerful. So lots and lots of buttons everywhere. I kind of don't like it for that reason. I just like issuing commands, right? I have a little tool called GitX. Let me just move that over here. And it's a little bit easier for me to read. And it's powerful enough for what I need. So it has like a nice little graph, which you can get to with just git log graph, right? You can get that too. You can see the various branches. We'll talk about branches in a second, but this is a branch that got merged back into master. So here's master, right? And then there are various branches that people have worked on and then merged back into master. And then you can also see, if you click this button, you can see sort of your working directory, unstaged changes, things, and then files that have staged. And then this is your commit. So it's sort of like 1, 2, 3. So I'll kind of demo that real quick. So nothing here, right? I'm going to just modify this file again, keep adding stuff to it. And okay, there it goes. So I have to click off. It doesn't refresh automatically. So if I click off it, click back, you can see that this is unstaged changes, right? And then what's great about this view is that you can highlight it and it'll show you a diff of what you changed. And then if you just drag it over here, this is like git add, right? This is git add. And then again, it has a diff there. And then if you're ready to commit, right, you can just write your commit message. What's also nice about this is that you can have a little bit more room to commit. So you can say complicated bug fix, right? Right, and you can say this impacts first the admin UI, another part of the app, right? And you can add more information there, and then you can commit, and that's now gone again. So that entire workflow that we just did can be done in this GUI. It's a little bit nicer to see, but when you use it, just make sure that you understand what's happening, right? It's doing a git diff, it's doing a git add, it's doing a git commit. And then if I do a git log, you can see a complicated bug fix. This impacts, right? So that first line of my commit message is here in this more compact view. And then if I look at it in more detail, you'll see that it is, the details are there, right? So it's nice to write a commit message like this sometimes. And if I do a git push, you'll see how GitHub renders this user interface, or the commit messages rather. So you can see that the first line there is shown here. And then if I click on this little thing, it shows up really nice as a expandable little widget here. So sometimes you see that and you're like, how did I do that? Well, this is just a merge. Actually, that's different. But you can write nice commit messages that way. How can you roll back diff? Yeah, we'll cover that in a second. Rolling back is actually really difficult. Okay, so this tip is about, once you understand the command line tools, use a GUI to help you, right? And this is really helpful when you have lots of files, right? So if I modify this file, and I modified this file, and I modified this file, if I go over here and I do a get status, right, you can see that it's kind of long to type out, right? So if if you have a big feature, a big bug fix, it could be, dozens of files, right? And if you are working with them, it's a little bit, sometimes it can get a little bit difficult to sort of manage them. And so if let's say you can just kind of look at this and say, yeah, I'm going to move this guy over to staged, move this over to staged, and say, oh, I changed my mind, move this back, right? So it's very easy to move things from your working directory to the staging environment or index, and back and forth as you see fit. And sometimes you want to group files into a logical commit. So suppose we have these 3 changes and they're all valid changes, but this file and this file combine for one logical commit. So then I would just move these 2 over staging and make a commit, right? So this is these 2 files, the changes in these 2 files are logically grouped together, right? So I can make a commit, and then I can commit this file so that my commit history looks good, right? So that it can say fixes, issue number 34, right? Unclear introduction, something like that, right? So these 2 commits fixes that issue, And then I'll stage this and I say fixes issue number 45, and that's just a typo, right? And again, if I were to do a get status, get log, you can see that it's sort of, it's nice to group your commits into a logical format. And one reason is it's just nice to see, right? I can click through on this commit and see everything related to fixing this issue, right? So if I were to go to fixes number 34, scroll down, you can see the 2 files here. Like, oh, these are all the changes related to that. That's nice to see. Also, we can revert this commit much easier in the future. If you say, wait a second, we didn't really want to fix that issue, right? Let's go ahead and revert it. It's all in one place. The worst is when you have lots of commits, and they're not logically grouped. They're kind of like little fixes all over the place, and it's hard to unpack a commit, right? You basically can't unpack a commit. You have to just create a new commit that then surgically repairs the damage. If you have multiple stage files that you want to group into separate commits, does it ever do that on CLI? Yeah, there definitely is. So the command line is a superset of the GUI, right? I just showed you the GUI because it's easier, right? We got to cover undo before we can do that, but yeah. Right, so if you have 3 files, you would just say git add, file 1, file 2. And the 3rd file is not added. It's in your working directory, right? And then when you say git commit, remember when you git commit, it's only from staging. It's not from your working directory, right? So does that make sense? So that's a good question. You're only committing things that are staged, right? So when you're working, like in other words, what's read, you can have like 4, 5, 6, 7, 8, 9, 10 files, doesn't matter. And then as you add those individual files to the staging area, they are sort of being prepared for the commit. So you can add 2 files only out of 10 that you're working on, and that could be a commit. Okay, use a GUI once you understand the command line. Really, really important. So if you ever are in a situation where I can do it from the GUI but not from the command line, not a good situation to be in, right? You should know how to do it in the command line, but maybe it's like, I don't want to type out all this stuff, right? I just want to click some buttons, but if forced to, I can type. So use branches. I'll speed up here a little bit just because we're running out of time. Branches are really powerful, and this is a set of commands, right, to use a branch. So branches, you can think of it as, if we go back to our graph here, you can see that there's no actual graph, it's just linear because I've been committing to master. But if you look at sort of the history here, you can see some sort of fork in the road. Like at this commit, there was a fork. At this commit, there was a fork here, and then it got merged back. This is because this author wrote this code on a different branch than master, and then merged it back into master so everyone else can see it. And the idea there is that we can all work individually on branches and not have a lot of conflict on master if we're all working on master, right? Remember, Git is optimistic locking, and that it is optimistic that you can resolve your differences, right? Pessimistic locking is we don't have to worry about branches because I'm locking the file, right? There's no way you can clobber what I'm working on because you just can't work on that file. I got it locked. I checked it out. So Git is optimistic in that way. So there's a very, very high chance that we can work on the same file together. And then when we try to merge, we just can't. There's a bunch of problems. So we use branches to mitigate that a little bit. It doesn't solve the entire problem, but it mitigates that a little bit. And that I'm working on this copy. I don't have to worry about whether or not you're going to come behind me and do something in that file because I'm on a different branch, right? And then we'll just worry about resolving that those differences later. Also, it helps with commit hygiene. We'll talk about that next. But the quick sort of summary branches of using summary commands of using branches is you say git branch, and then your branch name. Usually it's the bug fix or issue number that you're working on or something like that. And then you say git checkout new branch, right? So this is what someone asked earlier, why are we using checkout? What checkout says is you created a new branch forking off of your current branch. So whatever branch that you issue this command on, it's going to fork, basically make a copy, right? Usually that's master, not always, but usually that's master. And so you're branching off of master, creating a new branch, and just saying, this is my little area. I'm going to work over here on this thing. And, my collaborators can keep working on master, or even if I'm just working locally, I don't want to worry about master. And this happens a lot when you're working on a project and you have an idea you want to try. So you don't want to try your idea on master, right? You want to try your idea somewhere else, like a clean slate. And if it all goes bad, you can always go back to master and just be like, that was bad. That was a bad spike. Let me just throw away all that work. But more practically, what happens a lot is if you're working on, let's say the launch school application, and we're building a feature, a pretty complicated feature on master, and then somebody reports a very critical bug fix, and we have to fix that. What do? We're in the middle of some work. What do we do with all that work, right? So again, working off of a branch allows master to stay clean. And so if while we're working on this really complicated feature that takes weeks and weeks, if an emergency bug comes in, we will fix it on master and deploy master, right? And then we don't have to worry about this feature branch that we're working on. So, and then eventually we merge the new feature branch back into master. And then we worry about collisions at that point. All right, so you create the branch, then you check out the branch into your working directory. That's what checkout means, right? So now your working directory is this new branch. And on this new branch, you just make changes as usual. And again, we're working with commits, right? So you have to go through that whole thing, git add, git commit, except you're working off of this new branch. And then once you say, yeah, I'm at a point where this is good, I want to bring it back to master, then you git checkout master and git merge new branch. So you go back to master and you merge this branch into. So this is sometimes the cause of some issues where there's conflicts. We have to resolve conflicts. But roughly speaking, this is how branching works. I'll forego the demo. I was going to do a live coding demo, but live coding just seems like it takes forever. So I'll just forego that. But definitely play around with it. Check it out. Now, one of the results of using branches is that you're able to give a very good commit history to your master branch, right? And then you can delete your quote unquote feature branches. We call them feature branches because we build features. But they could be bug fixes branches, right? But just terminology, feature branches. So in your feature branch, you can feel free to commit as often as necessary and make all kinds of weird commit messages, right? Like work in progress. Like if you see a lot of commit feature branches, you'll just see WIP all the time, all the way down to WIP. Now, in a real project, right? Imagine if you went to some project history and all you saw was WIP. And you're like, what's going on here? I don't want to see all this. I just want to see when the feature is built, I want to see that, right? How was this feature built? How was this bug fixed? I want to see all the commits related to this bug fix. And again, we'll talk about later why it's so important to have good commits, right, that are logically consistent and are sort of atomic to one particular feature or one particular bug, just so that you can do things with it, right? You can move it around or you can revert it easily, right? If one bug fix touched 10 files and they're in one commit, it's just so much easier to deal with that as opposed to, one bug fix that touched 10 files, but it's scattered across 4 commits. So then when you work with feature branches and you merge back into master, we want to squash them. We want to squash all these messy commits. Oops, I keep clicking. You want to squash these messy work in progress commits, right? And so you want to do git checkout master, just as before, right? Git checkout master here after you're done making the changes and all these commits on your feature branch. But instead of just git merge new branch, you want to say git merge -- squash new branch. and then you can commit it. So now you've sort of merged that new branch in. Let's say there's 50 commits, right? And you've basically pulled all those 50 commits from that other branch into your master as one change. And now you can commit again with, a better commit message. And when other people look at the history, they'll see a very clean one commit. This is, a new feature, and here's all the, features of this new feature that we've just built, right? So it helps keeps your commit history clean. So a lot of times if you browse around GitHub or anywhere and you look at a project history and it's like, wow, it's so neat and tidy. How do they do that? This is how. It's not because they code that way, right? So nobody codes that way. Everybody, makes a bunch of random commits and stops and goes and all that. But just when they are presenting it to the world, they take time to squash it and make it look nice. Tip 9, undoing in Git requires a little bit of effort. It's not as simple as, I made a mistake, let me just undo that. So one sort of overriding philosophy of Git is that you only move forward. Like you might think, okay, if I undo something, and I'm talking about commits, right? And again, kind of back to this. If you want to undo something at this level, you can, but you have to rewrite history is what they call it, right? You have to rewrite the history of this repository, which is considered a very dangerous activity in Git. And so typically you don't want to do that, right? Typically, if you have a commit, you made a commit to the Git repository, and it turns out that that's not right, you can issue a command called git revert. So what git revert does is that it just creates a new commit, and it undoes that commit, right? And we talked about earlier why we want to group your commits into sort of logical things, logical containers. You can undo it pretty quick. So undo a commit with a new commit. That sounds crazy, but that's what we do in Git. Again, there's ways to not do this, right? So if there's something just really bad and like you committed a password, right, that you can't change. So if you undo that commit with a new commit, well, the password's still going to be in there, right? It's in the history. And you say, well, that, we have to remove the password, right, because we can't change it. Then that might be a good time to change history. But even then, it's dangerous to Git because remember, all your developers, they got that history on their local machines, right? So very dangerous. Unstage a file. So this sounds like it should be easy. Unstage a file is when we staged it. So let me go back. So I am clean right now. So I make some change here. Right, so I staged this. This is green. I staged it, right? To unstage this, it's so difficult that they have to give you like like instructions, right? So they actually say to unstage, use git reset head file name. Git reset head. We're back, right? So kind of difficult. So this is why sometimes I prefer the GUI tool, right? So if I look at my GUI tool, that's staged, double click unstaged, right? So unstage a file, unstage all files, a little bit easier, just get reset. Sometimes you don't want to unstage all files, right? But if you do, how to throw a file in the working directory, right? So always remember where the files that you're working with, where are they? Are they in the working directory? Are they in the index or staging area? Or are they in the repository, right? Or are they untracked? So if you're working on a file and you realize this is just completely wrong, and I need to just throw that away, if you will. You can do git checkout file name, right? And I'm going to just make some changes here, and I'll show you what that looks like in the GUI tool. So I have some changes here, right? I got some changes here. I added this. That's not good. I want to throw that away. So in the GUI tool, You can see that right there. I think I said unclick discard changes. Are you sure you want to discard? Yeah, and it's gone. Right, and that's the same as git check out that file name. Right, so because I was in a working directory, not stage, working directory, check out, gets rid of that. So sometimes you want to do something and you're not sure why. Just keep in mind, where is this file? Working directory, staged, and then how do I, if you know how to move it from one state to the other, then you can usually do what you want to do. And this is something that I alias because this happens all the time where you want to throw away everything in the working directory. And usually that happens when you're on a spike, right? You're kind of just making some big changes without really knowing if this is going to work. And it turns out it's not going to work. Or it turns out that you did in this research where you know how to kind of what direction to go, but you want to just throw everything away. You could do that. Or you can just use a branch and then just, go back to master, right? That's another way. Stashing work. So this is, I decided to cover this. It might seem random, but I decided to cover this because sometimes when you're working on a branch, and you say, I want to throw away this branch, right? So, so GB is my shortcut for a Git branch, right? So I have two branches now. I'm now at new branch, okay? I'm going to make a bunch of changes on new branch. And notice my little prompt change, which is nice. So I'm on new branch, and I'm just going to make changes on new branch, right? And then I realize, all right, this is bad. I'm going to go back to master because I just want to get rid of everything. And I'm going to check out master. So I can do that. But you see, this came with me, right? Like this change came with. I was like, oh, I want to get rid of it. I didn't want that to happen. That was, that's not good. I'm going to go back over here to new branch. Okay, so this is where we were. So I can say, okay, let me add this, right? And then let me go back to master. And it's still there, right? So that's sometimes frustrating because you're like, I'm trying to get rid of this. I went back to master to get rid of this. Now it's in master. It's pretty terrible. So once in a while, you have that need of just git reset hardhead, right? So it's, again, I've aliased it to get reset for me. And then if I look at it, you can see my latest is 645. And then you probably want to just keep your branches clean. And if you're not using, if it's a temporary branch, just delete it after you're done using it. Merge it back in master, delete that other branch, right? So it's not floating around. Last one is stashing your work. So a lot of times if you're switching, this happens when you're trying to push to GitHub or pull from GitHub a lot. So if you're working on something, right? If you're working on something and then you say git push, or if I do git status, git push origin master, kind of a bad example because let me do git pull. Okay, so if there were changes on GitHub, and I try to pull, actually I can probably simulate this by, so GitHub is kind of interesting in that it allows you to actually make commits right in the app. So let me see if I can do that. Edit. They used to let you do that. Let me see it. Well, okay. We're out of time anyway, but sometimes you want to stash your changes, right? So I have this file in the working directory, and I can't pull down changes from GitHub from any remote repository because of this. They'll say, you can't, you have, uncommitted files in the working directory. So the stash is basically like a stack that you can throw things on, right? And then if I do a git status, you'll notice that it appears like nothing happened. Like, that's it. If I want to bring back those changes that I threw into the stack, I just say git stash pop, and I'll pop off the top item in the stash and delete it from the stash. If I don't want to delete it, I can say git stash apply, right? And you can actually stick a lot of items on there. So you can keep saying git stash, git stash, git stash, and then it'll just save it into the stash of history. And then you can apply it with this at curly brace number. If you do a git stash list, it'll tell you. So this is a little, I use this a lot. I don't have anything in my stash right now. I use this a lot just because when you're moving things around, you have a lot of things work in progress. You're trying to, pull down a change or something like that. And just, this happens when you're working on a branch in the middle of something and somebody goes, hey, there's a critical fix, right? Take a look at it. So I'll switch over to master. So I'll stash what I'm working on because I'm not ready to stage it. I'm not ready to commit it. I'm not ready to do anything with it, right? So I want to stash it away into a temporary place. I'll switch over to back to master. I'll pull down the code that somebody said was critical, look at it and say, yeah, that's good. Let's deploy it, work on that for a little bit. And then after that emergency has been fixed, go back to whatever I was working on before and say git stash pop, right? And that will bring me back to sort of whatever I was originally working on. So stash is really, really convenient for that purpose. But you just got to remember it's kind of like a stack. So you pop things out of it, and you can, if you ever forget what's in there, just do git stash list. Squash or merging, is the branch deleted once? No, the branch is not deleted. So when you so git merge squash just merges all the commits in that other branch into your master branch, or whatever branch you issue that from. So this is, it's not you only issue that from master, but that's your typical workflow. Somebody asked about what the typical workflow is. That's it, right? Typically, you work on a feature branch using these commands. This is all local, by the way, right? So once you have the mental model of how to work on this locally, then you can apply that with in a remote fashion. So you'll see feature branches being pushed to GitHub all the time, too. How do you do that? Just Google that. It's pretty easy, right? And then you can work with somebody else, a teammate, on this feature branch, right? Not just by yourself, right? This is like single player mode. Once you understand single player mode, then multiplayer mode is much, much easier, right? And then once you merge that new feature branch into master or wherever you issued this command from, but usually it's master, right? Then you commit all those temporary commits, right, into a new feature, and then you push that. So I haven't talked about like remote repositories at all. This is just working locally, right? Because once you introduce remote repositories on top of this, you just have to add the initial command after this, which is pushing it to your remote repository. That's it. Right. So it groups all your commits in a different branch. It squashes them into one commit. So you have a nice commit history, right? So if you look around GitHub, let's look at Rails. Or it doesn't matter, but any, I don't know how to search for Rails GitHub. If you look at their commit history, it's pretty clean for the most part, right? You don't see a bunch of like work in progress. I don't know if this is going to work, right? They're merging in commits. Now, I don't think they squash. This is a preference thing. I prefer squashing. There's this big debate, and developers like to debate about everything, right? I prefer squashing. Some people are like, no, don't ever squash because I want to see history, even of your work, your feature branch. I want to see the history because that helps you understand like how that works. So, if you have a team lead like that, then you have to be careful even on your feature branch, right? You have to be careful about your commits because they won't let you squash. I'm a little bit more lax, right? I'll allow you to squash commits just because I don't want you to feel like you can't commit something. But if you do commit sort of little things here and there, just do it in the feature branch so that it doesn't pollute master, keep master clean. Right, so this is 2 files here for this one commit. So let's look at this thing that's merged. Oh, so these are all really tiny. Yeah, these are too small to really. This one's kind of a little big, but some of the bigger ones, they're tens of files, sometimes hundreds of files, really big commits. I would say if it gets into hundreds of files, it's probably too big because you can't really reason about it. So again, that's another thing about commit hygiene is depending on the size of your project, you want to at least be able to like mentally digest the goal of the commit, right? And if you click through, you can at least glance through and like kind of understand what files were touched by it. So that's it. Slides will be available, I think. The video will be available. But yeah, I guess we can make the slides available. Okay, any other questions? So this is just touching the surface of Git, and then Git gets deeper than this. And then on top of that, there's a lot of workflows that teams employ, like pull requests, code reviews, and there's this sort of reliance on GitHub more and more. And again, as beginners, I feel like try to think about Git outside of GitHub. Really try hard to do that. And then when you see GitHub building features on top of Git, it'll make a lot more sense. Otherwise, you'll just think that, and they want people to do that, right? They want people to think that GitHub is like, is Git, right? Is version control to some degree, but that's not so, right? And so, a couple last resources here. Atlassian has really good guides, and I think they did this probably because of this. So they have a Bitbucket bias. Atlassian owns Bitbucket. So this guide is, I think it's good. I think it's a good secondary resource for our Launch School Git book. So if you're brand new, I would say do the Launch School Git book, and then look at the Atlassian Git tutorials. The Pro Git book is really good. I think if you're serious about programming, which everybody at Launch School is, at some point in your career, you should read this book. I don't know if that should be now or not, probably not. But at some point, I would say make time to read this book. You'll see I grabbed a lot of pictures from that book. It's free. It has a GitHub bias, so watch out for that, right? So just be careful about biases. Like the author of this book is a co-founder of GitHub. And of course, this book is just Atlassian's URL. Right, so, all right, that's it. Hopefully it helps. Thanks, everyone.